This Zoom session is being brought to you by the fractal odd dyadic octaves BL. All right. Okay, for today, we're getting into trigonometric identities. Oh, wait. No, I am so sorry. My mistake. We did that last time. I clicked on the wrong one. Let me try that again. Okay. No. I recommend this section, as a mnemonic I picked up on the web somewhere, I forget where, a super hexagon for trigonometric identity. This little hexagon here with the one in the middle. And here are little tricks for telling us, so for example, opposite functions are reciprocals, like here. There's some rules about multiplication, and there's some rules about complementary functions, and there are rules about about the Pythagorean identity. Let's proceed on. My apologies. Let's move on to this. 3-5, sum and difference identities. These are tough, but I think they're I'm going to say beefy. They're savory. I like them, but they're tough. Okay, these are trig identities involving trigonometric functions of sums and differences. Trig of alpha plus or minus beta is what? We'll start with the cosine addition law. We'll start with this picture here, a unit circle with one angle, one unit interval up alpha degrees, and another one clockwise beta degrees, or beta radians, whatever. And distance 1 here and here, distance d between these 2 points. This point here is located at cosine alpha by sine alpha, and that's because this is an angle negative beta. This point here is located at cosine negative beta by sine negative beta. Now what you do is take this triangle and turn it by beta radians and get this triangle here. Still have a 1 here and here on these sides, and a distance d on this side, and an angle alpha plus beta. This point here is at 1 by 0, and this point here is a cosine alpha plus beta by sine alpha plus beta. Now, because these are they're what's the word? Congruent triangles with the same sides 1, 1, and the same angles alpha plus beta. That means that this side here and this side here are the same. This distance d is the same as this distance d. So their squares are different. D squared here is the same as d squared here. Now d squared, between 2 points, you can find by taking sum of squares of differences. So for example, here this d squared is the sum of cos alpha minus cos negative beta squared plus sine alpha minus sine negative beta squared of this side here. And it equals d squared here, which is cos alpha plus beta minus 1 all squared plus sine alpha plus beta squared. So we have this identity. Now, okay, expand these binomials. Cosine minus first off, cosine negative beta, the negative cancels. So this difference will be cos squared alpha minus twice cos alpha cos beta plus cos squared beta. And this, well, okay, here the minus comes outside, so you really have a square of the sum. And so its square will be sine squared alpha plus 2 sine alpha sine beta plus sine squared beta. This here, expand this to cos squared alpha plus beta minus 2 cosine alpha of cosine alpha plus beta plus 1. This is sine squared alpha plus beta. Now this is the point where we get to use the Pythagorean identities. Cos squared plus sine squared, cos squared plus sine squared, cos squared plus sine squared. Well, first I rearrange it. Cos squared plus sine squared plus cos squared plus sine squared minus this term 2 cos alpha cos beta plus this term 2 sine alpha sine beta. And this cos squared plus sine squared, put them together, plus 1 minus 2 cosine of alpha plus beta. All right, now these cos squared plus sine squared equals 1, cos squared plus sine squared equals 1, cos squared plus sine squared equals 1. So 1 plus 1 minus 2 cos alpha cos beta plus 2 sine alpha plus beta, 2 sine alpha sine beta, equals 1 plus 1 minus 2 cosine of alpha plus beta. Okay, cancel the 1 plus 1 on both sides. You get minus 2 cos alpha cos beta plus 2 sine alpha sine beta equals minus 2 cosine alpha plus beta. Now, divide by a negative 2, and we get cosine of a sum, alpha plus beta equals cos alpha, cos beta minus sine alpha, sine beta. This scribble is awkward. I should remove it in the canvas. Just 1 second. Scribble, page 2. Here. All right. Now, so cosine of a sum is cosine cosine minus sine sine. This is the cosine angle addition formula. Now, if you replace beta here, here, and here with the negative beta, see, this becomes cosine of alpha minus beta, and cosine of negative beta is cosine beta, so that stays the same. Sine of negative beta equals minus sine beta, so this minus becomes a plus. And I get that cosine of alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. This is a cosine angle difference law. If we substitute pi over 2 for alpha, and given that cosine of pi halves is 0 and sine of pi halves is 1, it follows that cosine of pi halves minus beta equals sine beta. That's the complementary law. We've seen this before. Now this is true for general formulas. And if you run this, and if you substitute pi halves minus beta here and here, and since pi halves minus beta is beta, we get the cosine beta equals sine of pi halves minus beta. So we, excuse me. So, okay, sine and cosine are complements of each other. We've known that a whole while, but that's convenient. Now, here we'll get to use this fact for figuring out the sign of a sum. Sine of alpha plus beta, we can write that as cosine of pi halves minus alpha plus beta on account of cosine and sine are complementary functions. And we rewrite that as cosine of pi halves minus alpha, that minus beta. So sine of alpha plus beta, this is a cosine of a difference. Cosine cosine plus sine sine. No. Excuse me. So I get cosine alpha minus beta. This should be a sine sine. My apologies. Okay, page 3. All right. So, and this cosine pi halves minus alpha is sine alpha, and this cosine pi halves minus beta is sine beta. So sine of alpha plus beta is sine alpha cos beta plus cos alpha sine beta. If you substitute negative beta for beta here and here and here, get the sign of a difference. Alpha minus beta is sine alpha cos beta minus cos alpha sine beta. All right. So far, so we go good. You have cos of sum is cos cos minus sine sine. Cosine of a difference is cosine cosine plus sine sine. Sine of a sum is sine cosine plus cosine sine. Sine of a difference is sine cosine minus cosine sine. Then there's tangent. Tangent is sine over cosine. So tangent of a sum is sine of the sum over cosine of the sum. That's sine cosine plus cosine sine over cos cos minus sine sine. We'll divide numerator and denominator by cos alpha cos beta. And you get some fractions cancel, and sine over cosine plus sine over cosine equals 1 over minus sine over cosine times sine over cosine. And since sine over cosine is tangent, you get the rule. The tangent of a sum is tang alpha plus tan beta over the quantity 1 minus tan alpha times tan. Okay, that's tangent of the sum. And if you substitute negative beta in for beta, this term switches sign, this switches sign, and you get the tangent of alpha minus beta is tangent minus tangent over 1 plus tangent tangent. Okay, so here these rules all summarized here. And you can find them in the book. So these are rules for cosine of a sum and difference, sine of a sum and difference, tangent of a sum and difference. These formulas. So, for example, cosine of 75 degrees. Okay, write that 75 as 45 degrees plus 30 degrees. Okay, and so this will be cosine cosine minus sine sine. Cos 45 degrees, cos 30 minus sine 45 degrees, sine 30. Cosine 45 degrees is root 2 over 2. Sine of 45 degrees is root 2 over 2. Cosine 30 degrees is root 3 over 2. Sine of 30 degrees is 1 over 2. And after a bit of arithmetic, that's root 6 minus root 2, all divided by 4. Sine of 45 degrees, we'll do the same thing. It's the sine of a sum, 45 degrees plus 30 degrees. And sine of a sum is sine cosine plus cosine sine, right here. And so sine 45 degrees, root 2 over 2, cos 30 degrees, root 3 over 2, cos 45 degrees, root 2 over 2, sine 30 degrees, 1/2. And after a little bit, that's root 6 plus root 2 over 4. Cosine of 15 degrees, that's cosine of 30 degrees minus 90 degrees minus 75 degrees. So therefore sine of 75 degrees, and therefore this, root 6 plus root 2 over 2. And sine of 15 degrees is sine of 90 degrees minus 75 degrees. And that's cosine of 75 degrees. Therefore this, root 6 minus root 2 over 4. Tangent of 45 degrees, well, 75 degrees. Well, that's tangent of 45 degrees plus 30 degrees. Tan plus tan over 1 minus tan, tan. That's 1 plus 1 over root 3 over 1 minus 1 over 1 times 1 over root 3. And after a bit after a bit, root 3 plus 1 over root 3 minus 1, which then we can simplify down to 2 plus root 3. And tangent of 15 degrees is tangent of 90 degrees minus 75 degrees, which is cotangent of 75 degrees, which is 1 over tangent of 75 degrees. So we 1 over this, 1 over 2 plus root 3. And after rationalizing the denominator, we get 2 minus root 3. Okay, this gives a trigonometry of 15 and 75 degrees. And I think those are very nice. And I think that the 15, 75, 90 triangle is as important as the 45, 45, 90 triangle and the 30, 60, 90 triangle. And it has nice formulas. They're quite easily legible. All right, now, so some examples. Now here they're asking to prove something. And in the homework, when they say prove, I want you to go through at least enough steps to make sure that it makes sense. Most of the other problems, I merely require the answer. Here, I want you to show the work, at least a little bit. So, sine of 3/2 pi plus theta is minus cosine theta. So we prove by going from left to right. The left side is sine of 3/2, 3 pi halves plus theta. And sine of a sum is sine cosine plus cosine sine. Sine 3 pi halves cos theta plus cos 3 pi halves sine theta. 3 pi halves is this 270-degree turn going to 0 by -1. So the sine of 3/2 pi is a -1. And the cosine of 3/2 pi is a 0. So putting a -1 here and a 0 here, you get negative cosine theta, or the right side. And the identity is proved. Here they ask for cosine of arcsine 5/13 minus arctangent 3/4. Okay, we're going to have to do 2 layers of trig identities here. Here, cosine of a difference, and then cosine of arcsine and cosine of arctangent. Okay, so here, cosine of a difference is cosine sine plus cosine cosine plus sine sine. All right, cosine of arcsine 5/13, cosine of arctan 3/4, plus sine of arcsine 5/13, sine of arctan 3/4. Now, okay, for cosine of arcsine 5/13, we imagine this triangle, the 5, 12, 13 triangle. Then you can check that this is the right triangle by Pythagoras. This angle here is arcsine of 5/13 because that's opposite over adjacent. And then by Pythagoras, you can find that this third side is 12. And okay, cosine of this angle is adjacent over hypotenuse, 12/13, which goes here. Cosine of arctan 5/13. Well, here's an angle arctan 3/4, 3/4 that is, opposite over adjacent. 3 and 4, and by Pythagoras, you can calculate the third side is 3/5. Cosine is adjacent over hypotenuse, therefore 4/5 here. So 12/13 times 4/5 plus Sine of arcsine cancels, 5/13. Sine of arctan 3/4. Well, by using this triangle, sine of this angle, arctan 3/4, is opposite over hypotenuse. That's 3/5, excuse me. So 12/13 times 4/3 plus 5/13 times 3/5. And after a bit of arithmetic, that's 63/65. Okay. All right, so these are, like I said, they're pretty heavy. They're pretty beefy, but I find them savory. So, okay. And next time, that's Tuesday, we'll get into something derived from those formulas, the double angle and half angle formulas, where we're trying to find cosine, sine, and tangent of twice an angle. And later, cosine, sine, and tangent of half an angle. And we'll get to those later. And then after that, a really beefy one. I think, however, quite useful. Product of sum and sum to product formulas. We start with those angle sum and angle difference formulas, and from that derive a way to turn products of trig functions into basically averages and half averages of trig functions, and sums of trig functions into products of trig functions. We'll get to that in due course. All right, we have done our section for today. I open the floor to questions, comments, requests, and suggestions. All right, then. Very well, then. Motion to adjourn. Is it seconded?
Yes.
Okay, thank you.
All right, then. I shall see you Tuesday.
Bye-bye.
Thanks, Professor.
Bye. Good morning. It's been real.
Just morning, not good. You're not like waking up early.
Oh, well, my attitude is this way I get the work done early. The very first thing I do every morning is feed the cats because, you know, they're the boss.
Rather have it still later though. All right, bye-bye.
Bye.
Professor, I got some questions.
Please.
So I tried to turn in the quiz one, but I couldn't find the submit button. So
It's inbox. You write it up, you scan it, you attach it to an email, and you put it into the inbox, you know.
oh, okay. So Canvas inbox and send it to you.
This inbox here, okay?
Got it. And I'm not sure if my book is different than your book, because one of
Sixth or
the
seventh
question-
edition, that maybe. Well, let me take a look. This is the 10th edition. Okay.
Oh, mine is the yellow one.
Which edition is that?
Let me see. Sorry, give me one more second.
Do you have a video cam?
No, I'm sorry, my phone cannot turn on the video. Yeah, I'm waiting for my new phone.
Okay, so be it.
Edition 11.
11. Oh God. I'm gonna have to change both my textbooks for next semester. Very well. Oh well. You can get the homeworks. I think.
I mean, I can find all the homework, like all the questions, but except the section 1.6 for the quiz. You asking us to do section 1.6. I believe it's 68. Question number 68, E and G. But
since I don't have edition 11, I can't compare it. I'm sorry.
oh, okay. But in
Go
my
to the
book,
library, I'm pretty sure they have an edition 10. And
yeah, in my book, it only have it didn't have E and G. It only have 48. Like
like
you only
I
have
said, in the library, they almost certainly have edition 10, and you can copy that off there. Okay.
Got it. Understand it. Thank you.
Thank you. Bye.
Thanks so much. Bye bye.
No problem. Bye-bye.